Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Haikal Shazwan. For Task 1, Introduction of Memory Forensic. Memory forensic is a part of digital forensic that focus on analyze a computer RAMs. RAMs hold temporary data like open app, password, internet activity, and even hidden malware. But once the computer shut down, all that data is lost. That's why memory must be captured quickly before it's gone. Memory forensic is very useful because it helps detect advanced threats like fileless malware. This type of malware runs only in memory and usually invisible by normal antivirus. By analyzing memory, we can find unusual process, suspicious network connection, or malware hiding in trusted program. As example, cyber attack and data breach. The two main tools we use is dump it to capture the RAM and volatility to analyze it. Volatility use plugin to show what was running in memory, including process, user session, or malware traces.
Next, I'm Yasmin will continue to explain about task 2, which is volatility installation and imaging RAM using dump it tool. So for task 2, both volatility and dump it are part of the RAM forensic process, which has been used sequentially but dependently. So volatility is basically a memory forensic framework used to analyze RAM dump or memory images. Meanwhile, a dump it is a memory acquisition tool to capture the contents of a system RAM. Thus, the forensic team will firstly use dump it to capture the RAM, then continue to analyze the captured RAM using volatility. So the first step is to download the volatility tree through GitHub. So to perform this, we need to open the GitHub link, download the zip file, and then extract the zip file to a folder. Then the next step is we need to install the Python. Volatility tree is a Python-based framework, so we need to download the latest version of Python and install it. Then check if the Python has successfully installed by verifying the version using command python-p in command prompt. Next, in step 3, we need to install the Python snappy library by run a command pip install python snappy. So it is a compression and decompression library. Without this library, the volatility is not be able to open or understand the memory files. And the next step is to install the Python package installer, which will allow any new libraries to be added into Python. Thus, we need to run the command pip install -e in bracket full. So by running this command, it will collect the libraries by downloading and installing them. Once successful, run the command pip install -e in bracket dev to allow an editable mode in install volatility. So in this picture, it shows that it collects data validation tools such as JSON schema and py installer, which is part of the dev tools that can be used by developers in volatility. And the final step is to display the information of volatility to ensure that the installed volatility tree is compatible with the system, confirm that the version is correct and it's working. So to perform that, run the command python vol.py-v. So once we run that command, the output will give a version and a usage of the installed volatility.
Now, let's move to the next part of task 2, which is imaging RAM using dump it tool. There are 5 steps in conducting this task. Step 1 is to download and run dump it tool. Dump it tool is already provided in the given link, so we just need to download, then open the software, which is dumpit.exe once installed. Then, it will show a window like in the second picture. Next, step 2 is memory dump confirmation. In the window, they will ask you if you want to continue. Here, we need to enter Y to proceed with the memory dump, and then we have to wait until the process is finished. Next, step 3 is monitor the memory dump. After the process completed, the tool creates a .raw file, which is the memory image. Then, we can locate this file in the File Explorer. When we try to open this image, it cannot be read because it is in .raw file type. Therefore, to discover its content, we need to run this file using volatility. So, in step 4, we need to open command prompt and use command cd to navigate to volatility folder path. Finally, we can analyze memory dump using command python vol.py -f followed by the name of the file and windows.info plugin. Windows.info plugin helps to extract basic information from the memory dump. As the result, we can see that the output confirms that the device is a 64-bit Windows 10 system with 8 processors. Machine type, which refers to CPU architecture type 34404, which is x64 architecture, and system root directory, which is C Windows.
Next, we continue to task 3, which is first analyze the malware.vmbm, which contains memory dump of a system that is infected with malware. Second, using tools like volatility, find and explain the following. First, machine operating system, including the version and architecture type. Second, infected process. Third, suspicious connection made. And fourth, other characteristic of malware. First, for the machine operating system, including version and architecture type. So for the command, we use the windows.info.info to get the detail. So here, -f malware.vmem is specific to the memory dump file that we want to examine. And then the windows.info is the volatility plugin used to gather the system level information from a window memory image. So for the version, we can see here the NT build lab is the 2600.xpsp, which indicate that we use the Windows XP SP3 build. And then the architecture type is the 32-bit with PAE enable. This is because we can see here IS 64-bit is indicate to false, so it is a 32 bits operating system architecture type. And then other detail that we can see from result of this command is the processor 2 and the kernel version is 5.1.2600. For the infected process, I use this command, the directory to the memory image, which is the malware.vmem windows.pslist.pslist. So I use plugin pslist to list the active processes running in the memory from a captured memory image that we want to examine, which is the malware.vmem. So here, as we can see, for the process ID 586 with the process name csrss.exe, have extremely high thread count, which is 3 to 6, that indicate to a possible compromise or malware injection. And then here also we can see some the multiple instances, which is possible process masquerading or injection under the name of the legitimate Windows update processes. So the name of process is wuauclt.exe and the process ID 1004 and 1588. And then in this output also we can see the various of process svchost.exe. So this process have the high thread. So normally in this process, the attackers inject the malicious payload because it is the common for malware to hide in here. So the high thread count may indicate to code injection or malicious thread spawning by malware. So this process may have been hijacked or used by an attacker. Next, for the suspicious connection made, I use this command. I use the connection plugin command. Actually, we have to use the netscan command to see the suspicious connection. But as I mentioned earlier, this is the Windows XP, and so the netscan cannot be run. So for the alternative way, I use a volatility 2 and then the Python below 3 to run this connection command. So here we can see the output. At the bottom of the output, we can see the local address, remote address, and the PID. So the connection plugin identified a suspicious outbound connection from the local IP, which is the 172.16.112.128, which is the private network, to a public IP 41.168.5.140
at 0 at 0. So the combination of the at 0 at 0, which is the non-standard port, the external IP destination, and random high local port 1038 is a typical of malware behavior, especially in command and control attack. So the associated process, PID 1484, is highly suspect and should be investigated further because it made a suspicious connection. Lastly, for other characteristic of the malware, we use this command, which is the malfind plugin for volatility tree to identify the injected code region in the memory, a common characteristic of the malware invasion. So here, as we can see, this command reveals two critical Windows processors, which are csrss.exe and winlogon.exe. So both of these processes have page execute read write, which is the typically abnormal in a clean system. It is because the process cannot run the read and write simultaneously. So this is a very suspicious process. So the presence of this RWX, which is the read write execute, is a classic malware tactic that is allow the malware to both write malicious code and execute it from the same memory region, bypassing the standard memory protection mechanism. And then, as we can see in the PID 584, there are some suspicious assembly instruction. For example, like XCHG and out and add. So this technique used by the malware loaders to ensure a reliable code execution. So there is also a message which is the found suspicious 30 plus page execute read for this process. So next we can see the PID 608. This process is very suspicious because all we can see in the block is 000. So the malfind result confirm the other common characteristic of the malware, such as the code injection into the legitimate process and the usage of the RWX, the read write execute memory.